So here's the AtomicLong adapter, which implements the AtomicLong interface so we can make it work effectively with the run test method. You can see we have a field here that's the AtomicLong itself. We have the constructor make an instance of an AtomicLong with the initial value. And then each of the methods in this class simply forwards to the corresponding method of the AtomicLong field. This is effectively the decorator pattern. So you can see we get the value here, we increment and get, we decrement and get, we get an increment, we get and decrement, and so on. And all those operations are guaranteed to be atomic. So this is kind of the baseline implementation. Let's now go take a look at the AtomicLong sync implementation. This uses Java's synchronized statements, which have been around since day one, and volatile variables, which were enhanced in later versions of Java, but have also been around for a long time. So how do we implement this? Well, AtomicLong sync implements the abstract AtomicLong, and it defines a value, a field called mValue. And the mValue field is defined as volatile. And that means we can read and write to it without it being protected by a lock and still be assured that it's going to be an atomic operation. Here's the constructor, stores the initial value. Here's the get call. It just reads the value. It's an atomic. It's defined as volatile, so that is guaranteed to be an atomic read. Here's increment and get and decrement and get and so on. They're all exactly the same. They use the synchronized block or synchronized statement mechanism in Java to go ahead and synchronize on this, and then they with that region locked, so it's a critical section, then they do the appropriate operation, either plus value or minus value or value plus or value minus, and so on and so forth. So very simple, very straightforward. As you'll also see, very, very efficient and highly optimized for this particular hardware, which is an Apple MacBook that's M1 Max. So very straightforward. Let's see if we can come up with some more interesting implementations that have other properties that might be desirable, however. So the next one we're going to look at is something that's called a VarHandle, or AtomicLong VarHandle. And this uses a feature that's been added relatively recently to Java. I forget what implementation, what version it was, but it was probably something like 16 or 15 or something. And it's basically a replacement. It's a portable replacement for the Java unsafe class and the various compare and swap operations that were defined there. This is a more portable way to do that. So here's the way it works. This is very canonical. It always looks this way. If you read Java code, if you read the AtomicLong code, it basically does it this way. It defines something called a VarHandle, which is static, and it's going to be used to access this field. So the way this works is we use a static initializer, which gets called before any instance of this class is defined. And it uses Java reflection to go ahead and use, get a VarHandle for this particular class that is associated with this field. So we say this is a type long. It's the mValue field. It goes ahead and finds and creates a VarHandle, and it stores it here. So here's VarHandle's value. That's where that is assigned. So by the time an instance of AtomicLong VarHandle is created, this will have already been initialized. And it's basically providing access, atomic access to this field. So let's go ahead and take a look at the various methods. Here's the constructor. It just stores that initial value into that volatile field. Here's get. It just reads the value of mValue, returns it. That's fine because it's volatile. But let's take a look at the various operations like increment and get, decrement and get, and so on. And you see that they're quite different. What they do is they use, excuse me, methods defined on the VarHandle, and we're using the same method every time. It's called get and add. Here's what get and add looks like. You can see it basically returns an object, and it takes a variable number of parameters. And in this particular case, we pass in this object, which is the particular instance of AtomicLong VarHandle that we're dealing with, and the value 1. And what it's doing is it's saying, get the current value and add 1 to it. So it's going to get the current value. So it's going to return the current value, it's going to update it atomically to have an extra, add 1 to it. And what this returns, as you take a look here, you can see it gives you back an object. We don't want an object. We want a long. So we have to cast that to long. And then we increment the return value by 1 because it's giving us back the old value, even though it's updated it to the new value. So we get back the old value. We add 1 to it. That's the increment and get semantics. Here is decrement and get. And you can see what it does here is it decrements the current value by 1. And then it gets back the old value, which we then subtract 1 from. And that's what we return as the result from decrement and get. Get an increment, as you can see, will get an add. So that's going to get the current value and then increment it. So we want the old value, so we don't have to do anything special to it. And get and decrement, likewise, we subtract 1 from it, but we get back the old value before 1 was subtracted from it. And that's what we're going to return. So that's the VarHandle version. And this is a useful idiom to understand if you have to write your own classes that want to access the lower level compare and swap operations, which is basically what this is. You want to use the low level compare and swap operations that are available in the Java virtual machine in a portable way.